Yeah. So today we're doing Liaison Chimique. So we started last time with Liaison Chimique, and today we're just going to wrap up. We're going just we're going to do the just how you can make covalent bonds. You know, covalent bonds which you already learned in Zambia, where a bond between nine metals, that's a covalent bond. So we are going to start on covalent bonds, and this is actually a topic which is a very simple topic, liaison chimique, and actually for me this is the topic which in Atomistique I liked, because it's a straightforward topic, and it's something which doesn't even need you to think all that. Yeah, if you just know how to write the electron configuration, those things, you never find any problem with this topic. So we'll begin with liaison chimique. So la notion in beginning, la notion de molécule étant la notion de molécule étant des concepts fondamentaux de la chimie. So we see that the connaissance or the knowledge of molecule, it is a concept which is a fundamental concept in can you get me clear? Someone saying my line is
No.
You can't get me clear?
We can now hear you. There was a point where you were speaking, we couldn't hear anything.
Oh, but now you can get me, my voice just okay?
Yes.
Okay. If we start cutting, you tell me, since you know these Wi-Fi things, they sometimes the network can be bad and it's cutting. I can't know from here. So you just tell me if it starts cutting. So liaison chimique. So as I said, la notion de molécule étant des concepts fondamentaux de la chimie. So we see that this connaissance or the knowledge of a molecule, it is a fundamental concept in chemistry, in chemie, in chemistry. So we see that, you know, a molecule is a lot of things, like oxygen is in form of molecule. The oxygen which you find in air is form of molecule. The carbon dioxide, and you know the importance of oxygen for breathing and breathing out. So the molecule is the concept fundamental de la chimie. So it's very important for us to start this concept of molecules in such a way that if you know how they form their bonds and how they how they combine and all that, if you know that, it will be easy for us to calculate other things or to know other things, how other things work. So the concept of molecules, something which is what very important. And une molécule est un groupe d'atomes qui conservent lors des changements d'état physique. So we see that a molecule, it is a group of atoms which is preserved during the change of the state, physical state. So physical state, when I say physical state, mainly I talk about the mass, those are the mass, or is physical, it changes from water to a solid form. Those are physical states. So we see a molecule always, if you're forming a molecule, it always depends on what bonding of two atoms which will come together, two or more atoms which will come together. And when they come together, for example, when I can give an example of carbon dioxide. Carbon dioxide will have an atom of carbon and oxygen. When they bond together, they'll form a molecule, and this molecule has a state physique different, or physical state different in terms of what? Mass, a different physical state in terms of mass. Since I can say for oxygen, oxygen gas is 16 times 2 is 32 for oxygen gas, and for carbon is 12. So when I add them, their mass molar becomes 44 grams per mole. So we see their physical state changing. So a molecule, when you say a molecule is, I'm not talking about elements which are just one by one on their own. No, I'm talking about elements which have come together and which are conserved during the changement of their the physical state when they are changing. So these are that's why you see the definition of on molecule et un groupe d'atomes conservés lors des changements d'état physique. So that's a molecule. So molecule depends with it. A molecule is when two or more atoms come together. So you should do, yeah. So this molecule can be formed by two atoms which are same or two atoms which are different. They can form a molecule. So that's why, like, if you remember, first I said, if you want to know, if they ask you a question, what's the difference between a molecule and a compound? So we see that a molecule can be formed with two atoms or two elements which are same or two elements which are different. It's possible. But a compound is always formed by two elements which are different. You can never find a compound with you can never find a compound which is formed by two elements only which are same. You can never find that. You always find there different, or two or more elements which are different for you to form a compound. So yeah, so here we see that each and every compound is a molecule, but not all molecules are compounds. That's what you should do, put in mind. So that's what you should do, have in mind. So now, having defined what a molecule is, a group of atoms which are bonded together to form, which are bonded together, having defined the molecule, now we're going to go further and see how these the bonding, how does the bonding happen in a molecule, or for us to form this so-called molecule. So we see that dans le chapitre précédent, on a vu comment les électrons sont répartis dans un atome. So in the previous chapter, we saw how electrons are arranged in just one atom. That when that atom is not bonded to another atom, when there's no bonding of it to another atom, we saw how the electrons are are arranged. Maintenant, on va donc étudier la répartition des électrons dans les molécules et rechercher les causes de stabilité des molécules. So now we are going to study how these electrons are arranged in a molecule, in atoms which are bonded together. How are these electrons arranged in atoms bonded together? And we're going to also search for its stability, when I say search for its stability, we know that when atoms they are coming to bond together, when atoms are coming to bond together, atom bond for one main reason, that's for it to attain its stability. So we're going to search for its stability. For this atom, how many other atoms are needed to be bonded to it for it to become stable? That's what I mean. For example, oxygen. Oxygen, we see that oxygen has the proton number or number of electrons 8, and if you write this electron configuration is 2,6, then the outer shell has we see that the outer shell has 6 electrons, meaning it needs 2 electrons for it to attain stability, and you are given hydrogen. So you see how many hydrogen does I need to have a stable atom of oxygen. So you see that hydrogen, since it has only 1 electron in the outer shell, so we need 2 atoms of hydrogen to have its stability. That's why they are saying rechercher cause the stability of the molecules. Yeah. So that's all that's what we are going to be studying. So those are the simple things. So if I think the way I've explained, you have something or you have an idea has come in your mind in such a way that you have learned these things already from your secondary, which is the making of an atom stable or bonding, the types of bonding, ionic, covalent bonding. You have done these things already, which means that actually this what will be something which is straightforward. So, en fait, alors de la formation de liaison chimique, seuls les électrons de valence interviennent. So, we said that for us we have to form some bonds, or we have to there should be some sharing or losing of electrons. So for us to do that, we know that the only electrons which takes part in this bonding, you should put this in mind, the only electrons which takes part in this bonding is the electrons, the valency. And the electrons, the valency, by definition, these are the electrons which are found at the outermost shell of an atom. They are the ones which always takes place in terms of what? Bonding. Yeah, to make you to understand more, I think I drew something. I drew an atom for you guys. Can you see my sharing?
Yes.
Oui.
And my voice, is it clear? I can get my voice very well. Okay. So liaison chimique, we said that electrons, the valency. So electrons, the valency. So we say that in fact, only the electrons, the valency, are the ones which takes place which takes part in this chemical bonding. If you are bonding something, only the electrons, the valency, are the ones which takes place. So what are the electrons, the valence? So for you to understand this topic very well, you have to have the foundation in such a way that you have to know what the valency, the electron, the valence is. If you know what the electron, the valence is, you will know how to, like this topic, liaison chimique, will be the most simplest topic for you. So electrons, the valency, are electrons which are electrons trouvent à la périphérique. Electrons trouvent à la couche externe. En autre terme, c'est electrons trouvent à la couche externe. So these I can say electrons, the valence, these are electrons which are found in the outermost shell of an atom, or in other ways, outermost shell of an electron, which is just the same as trouvé à la, or in other ways, I can say electrons which are found external electrons, like the last electrons, in other words. So, for example, I'll give you oxygen. Oxygen. So for you to write the electronic structure of an atom, first you have to write its electronic configuration. So oxygen has 8 electrons. So you write 1s2, 2s2, 2p4. So now when you're writing this electronic structure, you know that I told you, if you remember, you should always be putting this. When I'm starting with an S, it means that's a shell. Like each shell starts with an S. So 1s2, it means that's the first shell. 2s to the power 2, since there's an S, it means I've gone to the second shell. So each shell begins with an S. So I have 1s2, which means in S2 there will be 1s2. This is 1s2. There will be 2 electrons, which you are seeing here. Then 2s2, 2p4. This is one shell. So 2 plus 4 is what? 6. So the outer shell must have what? 6 electrons. So the 1, 2, 3, yeah, if you see 1, 2, 3, 4, 5, 6. So there are 6 electrons in the what? Outermost what? Shell. So after I've seen, this is for oxygen. Then for hydrogen, so I want to bond oxygen and the hydrogen. Hydrogen, I only have one S1, meaning it only has 1 electron in its outermost shell. So it will be 1, yeah, hydrogen, it will be what? 1 electron in its outermost shell. Yeah, and for you, you know that for oxygen to be stable, it needs to have 8 electrons according to if you remember the formula which we use for stability. If you remember the regular the stability, we use 2n2. We know that the first shell it will be 2, 1 to the power 2. The first two, which is 2 times 1 to the first two, it represent the number of electrons which each orbital must have. Then 1, 2 is the shell. 1 is the shell. Then you just square that one. So you have 2, and it means the first shell must have 2 electrons. Then the second shell, so on, so forth. If you remember, I think I have something here. Yeah, we said for us to know. So this is each. We know that each shell or each orbital must have 2 electrons in it. So for me to find the number of electrons in this shell, I use this formula 2n squared. So I know that 2 times n squared, where if there's first shell, where n will be 1, then I have 2 electrons. If you to be the second shell, n will be 2, then in that shell, I must have what? 8 electrons. So this brings us here in such a way that the oxygen shell, since it is the second shell, it must have 8 electrons for it to attain stability, for it to be stable. So meaning it will need, since hydrogen only have 1 electron in its outermost shell, it will need 2 atoms of hydrogen for it to attain stability. So here the main issue or the main thing which I want to bring in, into consideration is we only use the electrons which are outside. We don't use the electrons which are inside. So the chemical bonding only takes place with the electrons which are outside because these electrons are not stable. If you see the electron in the first shell, there are 2, which meaning they are all, the first shell is already full, it's already stable, but the second shell is not what? Stable. Then for this one, we see that there's only 1 electron, which means it's not stable. It needs 2 electrons for it to be stable. So if you see here, it will be 1, 2, 3, 4, 5, 6, 7, 8. This one is stable. Then hydrogen also is stable. 1, 2. 1, 2 is stable. So that's what we usually use, or when you talk about bonding, just think of electrons which are found in the outermost shell. Yeah, that's what we mean when we talk about bonding. So these are things, I think these are things which you did already in Zambia. I don't know if there's any question on an introduction before we go to liaison covalent. Is it clear or should I?
It's clear.
It's clear. Okay, so basically here, we are just going to look at bonding. So we're going to start with liaison covalent. So liaison covalent, just covalent bonding, which we, like in Zambia, back from a secondary, we learned that there's ionic bonding and the covalent bonding. Ionic bonding is the losing or gaining of electrons. Then covalent bonding is the sharing of electrons between what? 2 atoms. So it is sharing. So in liaison chimique, we are going mostly to depend, or we're going to mostly talk about liaison covalent. So we're going to look at covalent bonding. So Quand deux atomes se trouvent en contact, ils peuvent mettre en commun leurs electrons de valence and form une molecule. So we see that as we know, when two atoms are found in contacts, they'll share their electrons, the valence, as I showed you, they'll share the electrons, the valence, and form a molecule, as I showed you for oxygen and hydrogen. They'll share it and form a molecule, like for example, H2O, which is for oxygen and hydrogen, which I showed you in the example. And la liaison qui s'obtenait par mise en commun des électrons est une liaison covalente. So liaison covalente is simply a liaison which there's a sharing of electrons between what? Two atoms. There is a sharing of electrons. It's not ionic is different in such a way there's a gaining or losing of electron, but for ionic is one gains, the other one loses. But for covalent, it's both of them they share electrons. Yeah, that's the difference. So after that, after we've known what covalent bonding is, we're going to know what's regular the octet is, and the regular the octet. We know that regular the octet says that if I can remember correctly, from our secondary, we learned that regular the octet, it says that the electrons in the outermost shell must not surpass 8. That's the regular, the octet. That's what it states. And we know that for it to be stable, it must be 8. It must be 8, and it must not pass 8. If it passes 8, meaning it doesn't obey regular the octet. So we see that we see this phenomenon here. We see that an atom, à l'exception de hydrogène, tend à saturer d'un octet d'électrons sous sa couche externe pour avoir la configuration électronique stable du gaz layer le plus proche. So we see that an atom, except the atom of hydrogen, they tend to go towards octet. The octet is 8. They tend to go towards octet. We know that if an outer shell has 8 electrons, meaning it's full, meaning it's stable. So they tend to go to this octet, and when it reaches this octet, which is 8, it becomes stable. Then the question which you might ask me is, why is hydrogen an exception? Yeah, that's the question which you might ask. Why is hydrogen an exception? Why does it not follow the octet rule? So that's the question which I'll answer. Yeah, I did something just. Yeah, I hope you can see my sharing.
Yes, we can see it.
Yeah, so I'm just trying to explain why does hydrogen do not obey the octet rule, but these others they obey octet rule, but hydrogen is an exception. So we see that for hydrogen, it has 1 electron in its outermost shell, and when when we want to form a hydrogen molecule which is stable, it means you have 2 hydrogen, and this hydrogen will bond towards each other, and they'll give you, if they bond each other, the number of electrons which they'll give in the outermost shell is what? Is 2, which is not even equal to 8. So when I say regulate the octet, I mean when I make that atom stable, that atom must have 8 electrons in its outermost shell. That's when it obeys octet rule. But if I make that atom stable and it doesn't even reach the 8 electrons, then it means it doesn't obey octet rule. So there's hydrogen, one of the atoms which doesn't obey octet rule, and there are also atoms where you find that there's the first shell, the second shell. Since we say that the first shell is 2 to the power 2, which will have 2 electrons in the first shell. The second shell is 2 times 2 to the power 2, which will have 8 electrons. And when you go on, the third shell will have 18 electrons. And 18 electrons for it to be stable, meaning it surpasses 8 electrons, the third shell. So there's some electrons which gives you 3 shells, maybe some atoms which gives you 3 shells. Excuse me. So there are some atoms which gives you 3 shells, 4 shells. Those, they don't obey octet rule. So the ones which only obey octet rule are the ones which will give you, if you write their configuration, they'll give you 2 shells. Like you feel the electrons in these two in 2 shells. So most if you consider, most are non-metals. Most are non-metals which share electrons. We know that metals for them is a different way, is something which is different in such a way that it loses electrons and it gains electrons, all that. So for ionic bonding, again, if it has, for example, if it has 3 shells, but the last shell has 1 electron, it loses that 1 electron, meaning it will just remain with the second shell, which has 8 electrons, which can also follow the octet rule. So octet rule is only dependent on 2 electrons, which have, the first one must have 2, and the second one must have 8. If it has a third shell which surpasses 8, it means that one won't observe octet rule, but exception for ionic bonding or atoms which lose or gain electrons, an exception for basically atoms which lose electrons, for those who have 3 shells, but they lose the electrons on the outermost shell, the third shell, the one remaining with 2 shells. But for those who have 4 shells, that one they can't follow octet rule, since you know that the third shell will be filled with 18 electrons. So that's all about it. That's what we should know about the octet rule. So here, like when I'm going to discuss, about the liaison chimique, we're going to discuss basically on atoms which does not pass octet rule. So we're going just to discuss atoms which can only end on the second shell. When you write their configuration, it only end on the second shell. So those are the atoms which are going to talk about. Those are the atoms which are going to talk about. That's why you have seen I've brought in octet rule, and we're not going to go further. Well, we'll go to 3s, 3d. Those, no, we want to go that far. So it'll be just 1s, 2s, 2p. That only the second shell, that's what we'll be talking about. So that's what we'll be talking about, because when you go to 3s, 3d, in terms of when you're writing this molecular diagram, it's something which is very complicated. Yes, something which is very complicated, because 3D, you'll see that according to orientation, 3D is something which is, the orientation is something which is complicated. Even those who found the orientation, sometimes they get confused by it. So they said when you're calculating, when you're finding the molecular diagram which you learn, we should always consider the atoms which end in which end with either 2 shells or which has 1 shell, because 1s is something, or s, orbital s is something which is very simple, like to write. It's something which is very simple to write. So here I just showed you how oxygen respect octet rule. So we see that 2 oxygen gas. The first one was hydrogen, which does not respect. Then oxygen gas. When it's 2 oxygen gas, I'll write this configuration first. Then after writing this configuration, when I try bonding them together, you see that if I count the number of electrons, it will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, which means it accepts the octet row. So that's what we'll be dealing with. So we'll be dealing with those which accept octet row and those which are found in the only maybe S shell, first shell, and second shell. So our limit will be second shell. So we won't go any further from that. So that's what we'll be doing basically. When you come to write the molecular diagram, which you see, yeah. So that's all about it. Octet row. I don't know if it's clear about octet row. Is there any question?
It's clear.
Yeah, okay. So yeah, so like actually, I think I'm just doing a recap, like just reminding you guys things which you already did. Then model the Lewis. So in secondary, actually, we only did how to write the structure electronic when using when using your shells, like the first shell must have 2 electrons, all that. But there's another way of writing, another way of showing this bonding, the chemical bonding, just using model the Lewis. So Lewis formulated the formula in such a formulated the, I can say, a method of how we can draw the chemical bonding or how we can show chemical bonding of atoms without writing their electronic structure, the shells, that one for the shell. So that's what we are going to, when you hear model de Lewis, that's what they mean. So that means on commande des électrons pour former une paire électronique est représentée par the Kadash, this Kadash here. So we see that la mise, the putting together, or the bonding together of 2 electrons, which forms a pair, or it forms a pair of what electrons? You bring 2 electrons when you bond them together. When they're bonded together, for you to form an atom which is stable, they'll form a pair of what? Electrons. And that pair of electrons which is forms when it is bonded together, it is represented by this color in the dashed line, which you see down here how we should do write the Lewis structure. If you are asked to write the Lewis structure. So Lewis structure, for example, you are given, so under Lewis structure, what you should always notice, one, you use the element. So first, you just write the symbol of the element which you have been given. And after writing the symbol of the element which you have been given, you write the outermost electrons, the electrons which are found in the outermost shell only. Don't write the electrons which are found in the, if there are 2 shells, don't write the electrons which are found in the inner shell. Just write the electrons in the outermost shell. You just write representing it in form of what? Dots. So Lewis formulated the formula in such a way that these electrons were represented, the electrons which are found in the outermost shell, they were represented in the form of what? Dots. So let's get an example. Let's say we have an atom a molecule, yeah, atom A. So we have a molecule of A which has got 2 atoms, atom A and atom A. So this atom has 1 electron in the outermost shell, and this electron has what? 1 electron in the outermost shell. So these electrons will be shared what? Mutually, like will be shared. So this A will share its what? Electron, and this here will share its electron. Then after sharing its electron, you have something like an electron here and an electron here, and this electron, the sharing of electron, will be just represented by a straight line. This is representing that there is a pair of electrons here which have been shared, 1 electron and 1 electron which has been what? Shared. So this one represents what? A pair of what? Electrons. Then we can get a practical example of hydrogen. Hydrogen is made up, the molecule of hydrogen, which is H2, which is made up of 2 hydrogen atoms. So you know its form as 1s1. So you know that it has one electron in its outermost shell. So the one electron will bond with it. The other one, so the hydrogen, this one, the one atom of hydrogen will share its one electron with it, the hydrogen in another atom for it to gain what stability. So when it shares, you have this line represents the two pairs of electrons. That's why you are seeing they got dot up and down. So here I was just trying to show you that there are two pairs of what electrons, and at the end you just write it as you write it. You don't put the dots when you write the final answer. It's just a straight line. So here when you finish, you just write a straight line, and this line, as I said earlier, it represents the pairs electrons which are it has what shared. These electrons which it has what shared. So that's how we write Lewis structure. So as we go on, we can also see for hydrogen and the fluorine. Fluorine has a proton number of 9, which means it has 9 electrons. And if you write this configuration, you have 1s2. This is the inner shell, 2s2. The second, the outer shell, 2p5. Yeah, this is the outer shell, 2p5. Yeah, so we see that 2s2 and 2p5. So in the outer shell, we have 2 plus 5 is 7. So we have 7 electrons in the outermost shell. So you see that this one is 2s2, which has 2 electrons, and 2p5. We know that for a p block, for it to be stable, for it to be stable, for it to reach maximum, its maximum is always 6. And for you to know is what is to know its rooms or orbital, you just have to divide that 6 by 2, then you know it's 3. So that's why you have seen 3 rooms. And these 3 rooms, you see that I'll first put 1, 2, 3. Then here, I think there was supposed to be the one down, yeah, then down, then there was supposed here, I think you just can see it like when I was writing, but there are 2 here. There are one down, one up, down, then there's, so you see there's this one, the fifth one, which is alone. So this one is the one which you take part in. This one which is alone is the one which you what take part in sharing in such a way that it will share its one electron. And for hydrogen also has 1 electron in its atom shell. This 1 electron which is just up, it will share it also. So we see here hydrogen shares and the fluorine also shares. Then you just represent it as a line. Then these 2 electrons here, you just, since they're a pair is just represented by a line. Then here also they're a pair, just represented by a line. Then that the down party also is a pair, you just represent it by what? A line. So that's how you write Lewis structure. And the other thing is, for you to know how many bonds this atom will have, you have to know what does it, how many electrons does it need for it to attain its stability. So for fluorine, if you add 2 plus 5 is what, 7. And how many electrons does it need for it to have its stability, to reach its stability? It needs only what? 1 electron. That's why you see it will only get 1 electron from hydrogen. And hydrogen has 1 electron in its outermost shell. It means it also needs 1 electron for it to be stable. So that's why you see the fluorine will give 1 electron and the hydrogen will give this 1 electron. So if you are to count the stability or the number of electrons for hydrogen, you count it to be 1, 2. So hydrogen is stable, 2. Then fluorine is 1, 2, 3, 4, 5, 6, 7, 8. So it's stable. So hydrogen is stable and fluorine is stable. So when you're writing the Lewis structure, basically you have to. Yeah, Kondwan, you have a question you can ask? Kondwan, I saw your hand, you raised your hand. I think it was a mistake. Yeah, so for you to write the Lewis structure, you have to consider the stability. How many electrons does hydrogen needs for it to be stable in the outermost shell? You say, since it has one electron in the outermost shell, it only needs another one electron for it to be stable. So it only get one electron from fluorine. And fluorine, how many electrons does it need? It only needs what? One electron. So both of them, they'll just share what? One and one electron. So one electron from hydrogen and one electron from fluorine. And when you calculate when you count your number of electrons on both sides, so since these ones on the middle, they are shared, so they are considered for fluorine and they're also considered for hydrogen. That's what you should do. No. Then for oxygen, yeah, also, so like for oxygen, I try to yeah, before we go to that, if you see here, oxygen, if you get oxygen gas, it has two atoms. Oxygen gas is made up of two atoms of oxygen. Then oxygen gas has the proton number, which means the electron number of 8, which means it has if I write this configuration, electron configuration, you have 1s to the power 2, 2s to the power 2, 2p to the power 4. So the outer shell, how many electrons does it have in the outer shell? So just add 2 plus 4, which gives us what? 6 electrons in the outermost what? Shell. So for me to write its Lewis structure here, I did something for you guys. An example for us now to write this Lewis structure. First, you write the electrons which are found. So this is the element of oxygen, and its electrons which are found in the outermost shell. After we add 2 plus 4, it gave us 6. So to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you have written the electrons first. After writing the electron first, one electron would you try this hydrogen will share one electron, and this hydrogen will this oxygen will share one electron, and this oxygen will share what? One electron. So they have shared the electron, and after sharing the electron, you try counting now. Has it observed octet through, or has it reached octet through? So it will be 1, 2, 3, 4, 5, 6, 7. This one hasn't reached octet through. It has 7 electrons. 1, 2, 3, 4, 5, 6, 7. This one hasn't reached octet through. It has what? 7 electrons also. So for me to reach this octet room, this one will give its electron and this one will give its electron. Now I will count again. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we see that it has now reached this what? Its stability. There are 8 electrons in the outermost what? Shell. So for it to reach its stability, it needs 2 electrons. So these are electrons which are in the middle. You should always know that these are electrons which are shared on both sides of the atom. So when I'm calculating its number of electrons, when I'm calculating for this oxygen, let's say this is oxygen 1, I'll include the electrons which are in the middle, oxygen 2. I also include the electron in the middle for me to calculate this what? Electron configuration. Then which will give me this one. Since it's a pair, I said the pair was just represented by a line, so we just represent a line, the last answer, a line. Then there are 2 here, they're also making a pair, we just represent it by a line. There are 2 here, which is making a pair also, a line. Then there are 2 here, a pair, a line, and 2, the other side, a line, a pair. So that's how you write it. That's how basically you write Lewis structure. So most of the question they'll give you atoms and they tell you no, write a Lewis structure for this and this atom, and you have to know. So the first thing is you write the configuration first. After writing the configuration first, you only consider the electrons in the outermost shell, and you should always put in mind that when I start at S, each S it means is another shell. So if I have 1s squared, the 2s squared is another shell. That's what you should put in mind, and you never go wrong when writing Lewis structure. Then we have NH4. positive. Now the problem comes in, if you have been given a positive ion, how can you write its Lewis structure? If you have been given an atom which has a compound which is in form of an ion, and for this one we see that there's NH3 plus H there's NH3 plus H ion or hydrogen ion. So hydrogen ion, we know that if hydrogen is an ion, it means that it has what? Lost its electrons. So meaning hydrogen doesn't have any electron in this shell. Like the shell is empty, doesn't have any electron in this shell. So how can you bond if you have one atom which doesn't have any electrons in its shell, and there are other atoms which have electrons, which if you add them, it will give us something like this. So how do you bond them? So what you should know, first of all, your bond, this one we have learned is something which we have already learned for this one, where it's something which very simple, such a way that for nitrogen, you have to, that nitrogen is proton number 7. Then you have to write this configuration. You have written this configuration, and after writing this configuration, its outermost shell, it has what? 5 electrons. Its outermost shell. So you say, how many electrons does it need for it to be stable? For it to reach 8, you know that it needs 3 electrons. So it means that it will form what? Nitrogen can form what? 3 bonds with hydrogen. That's why you have seen H3, meaning it needs 3 hydrogen for it to reach what is stability. So just put the hydrogen, and you do the pair thing. So out you write first the electrons. There are 5. So you say 1, 2, 3, 4, 5. These are the electrons out. Then you first do for this one which you know already. You bond it, and you bond it to hydrogen. Now what happened for this ion, hydrogen ion, which doesn't have any electron in its outermost shell? So since it doesn't have any electron in its outermost shell, and you know that hydrogen needs 2 electrons for it to be stable, so which means in this case the nitrogen atom will share all its electrons, these 2 electrons, to hydrogen, and it will form a liaison called liaison dative. So this is a liaison dative, simply a liaison where one has no electron in its shell, and all the electrons are coming from one atom. So here in this case, all the electrons are coming from what? Hydrogen, are coming from nitrogen, and the hydrogen is a positive, it doesn't have any electrons in its shell. So it's possible for you. Sometimes they can give you a compound like this, and they tell you write its Lewis structure. So what you should know is first you have to write the configuration of nitrogen, and you find out how many electrons that hydrogen needs, for nitrogen needs, for it to be stable. Then after finding it, then you know that how many hydrogen should be bonded to nitrogen for it to be stable. We know that there are 3 hydrogens, since each hydrogen has 1 electron. Then after you have done your bonding, that's when you consider the positive one now, which has no electron. What should I do to it? So we see that nitrogen gives all its electron to this atom. Yeah. So if you can see an example, I did an example. Yeah. If you can see an example here, this is nitrogen. So what you see here, just the same thing. This is nitrogen. So there's hydrogen. This is for atom of hydrogen. There's a sharing, and there's also a sharing. So it doesn't matter. Here my hydrogen positive, I'll put it down. So don't get confused. It doesn't matter where you put it, as long as you have arranged it. You have drawn your what. So here is just a diagram which I'm trying to show you. So H positive, it means it doesn't have any electron in its outermost shell. So here you know that with this one I've already learned it. This is the simple way of bonding, which you have already learned. Yeah, just bond. After bonding, then this one here, since it doesn't have any electrons, then nitrogen will lose or share all its electrons. It will not lose, but it will share all electrons. Get me clear on this one. It will share all its electrons. So when it shares, it forms a molecule like this one. So it will have, if you see here, there's X, the dot, X, the dot, X dot, but here there's XX, meaning nitrogen has shared all its electrons. So basically that's what happens. Yeah, that's just a diagram, just to show you. But model the Lewis, you just use an element and the electrons in the outermost shell. That's what you do for model the what? Model the Lewis, basically. Yeah, I don't know if it's clear under model the Lewis. If it's not clear, I can ask your questions. Can you get me clear, or my network is bad? Is it clear?
Yeah, it's clear.
Oh, it's clear.
So basically, that's under Lewis. So don't get confused when you are. So I'll try, like I'll create some questions for you guys. I'll create some questions, and those questions I'll send it to you so that you try just to how you write. You try your Lewis the structure, and also you also try the other things which we did. So I'll give you some questions. I'll make some questions for you guys, and yeah. So after we have, so that one Lewis structure of Lewis is after we've done structure of Lewis, that's how you should do always. If they ask you to write or to present the structure of Lewis, that's how you should always present it. Now we're going to go to something which is very interesting, which is actually the heart of the topic, which is the theory des orbital molecule. So the theory des orbital molecule. So here we're going to learn what really we're going to learn. This one is I found it really interesting in such a way that we're going to learn how these atoms bond actually. What really happens when these atoms are coming together, the theory of orbital molecule. So we're going to learn what really happens when these atoms comes together. And we're also going to learn an amazing part in such a way that you guys never even imagine that you can write an electron configuration of a molecule. So we're going to learn how to write this electron configuration of a molecule, which is something interesting also. So these things are, I'll just need you to follow me as I start explaining. These things are very simple. If you just follow me, these things are very simple. So that's what we're going to learn about under theory, the orbital molecule. So this theory is something which is simple. I can say something which is very simple in such a way that we're just going to learn how atoms bond, all that. So that's what we're going to learn. And under theory de orbital molecule, on considérait que l'orbital moléculaire est une combinaison linéaire d'orbitales atomiques obtenue par resolution des équations de Schrödinger. So we consider that the orbit molecule is the structure which it forms after these molecules bond together. What structure does it form when these molecules bond together, and how many can it only bond in one? So we're going to also learn, can it only bond in one way, or it can bond in another way? So those are the things which we're going to basically learn about this one. So what when we consider orbital or molecule, which is represented by psi. Psi simply is here is just the it represents the orbital. Yeah, the psi represents the what? The orbital in which this electron is found. What orbital is this electron found? That's what this psi represents. For example, if it is in the phase shell, we know that it's found in the what? The phase shell has only one s, which means it has only one orbital. So that's how we're going to what? To do about this theory orbital. So for psi, you should always know it represents what? Orbital. And it is, so when you say orbital moléculaire, est une combinaison linéaire des orbitales atomiques. So this is a combination of, a linear combination of orbitals, like different orbitals or same orbitals. If it is in the phase shell, we have the s orbital and the s orbital, they combined. That's how you form, like that's how you form a molecule most of the times. And this orbital is obtained by the resolution, the equation, the Schrödinger. So equation, the Schrödinger simply, so when you see the equation, the Schrödinger simply, it tells us how many, as we learned, it tells us about the orbital and all those things. So we see that the psi only represents what? The orbital. And yeah, the psi, when I say the psi, it represents the orbital. Is it in S, is it in P, or is it in D? That's what it represents. Is it in the first shell, on the second shell, on the third shell? The most simpler way, that's what I can say. So how do these molecule bond actually? So for us to know the combinaison linéaire de orbital atomique, we have to know how does this atom bond. For example, we're going to take for hydrogen atom. How does a hydrogen atom bond for us to for it to give us a molecule? So that's what we're going to consider for hydrogen atom. How does the hydrogen atom bond to give us a molecule? So we will learn that this hydrogen molecule bond in two ways. There are two different ways in which this hydrogen molecule can bond. So I drew something for you guys. Can you see my sharing?
Yeah, we can see.
Yeah, I drew something for you guys. Yeah, even though it's not that clear. So theory, the orbital molecule. So how does hydrogen atom bond? So that's what we're going to learn here. So hydrogen atom, if you see hydrogen atom, if you try to bond hydrogen atom, so if you bond hydrogen plus hydrogen, it will give you a hydrogen gas. This is the hydrogen gas which it will give you. So what really happens when this bonding is happening? So what happens is, assume this is an hydrogen atom 1 and hydrogen atom 2. And this is, even if though it's not that clear, this is a nucleus, this is a nucleus, and in between here, this is a what? This is an electron, and this is an electron. So what usually happens? So you know that when these hydrogen atoms, they are far from each other. So imagine these hydrogen atoms, they are far from each other, and they are trying to come together. They are trying to bond to form a molecule. So these hydrogen atoms, when they are far from each other, we know that they are stable because each one has one electron in its outermost shell, meaning it's not yet, they have not yet bonded, and they are unstable. So what usually happens is, if they have started coming together, they will start coming together in such a way that, because one reason why they will start coming together, because this electron here on the hydrogen 1 is attracted by the nucleus here in hydrogen 2, and this electron here in hydrogen 2 is attracted by a nucleus here in hydrogen 1. So they'll start coming together. So when they start coming together, the electron force is increasing, the attraction between the electron of hydrogen 1 and the nucleus of hydrogen 2, and and the attraction of electron of hydrogen 2 and the nucleus of hydrogen 1 start increasing. And if the electrostatic force is increasing, it means energy is what? Reducing. For something to be stable, the energy has to reduce. So when it's coming together, imagine it's coming together, the energy is in what? Constant reduction. You know that if you remember under Bohr, we said that if we excite an electron, this electron, it will gain energy. When an electron absorbs energy, it becomes excited and it gains energy and it moves out of the shell. I think you learned that. And when it moves out of the shell, it becomes unstable. And these atoms of hydrogen, they are very far from each other, which means that they have one electron is out of the shell, which means that their electrons, they are what? They are unstable because they are unstable because they haven't reached the maximum number of electrons in the atom shell. For n is equal to 1, you know it's 2. So they haven't reached, so they are unstable. So when they are coming together, their electrostatic force is increasing and their energy is reducing and they become more and more stable. So this one was represented by a diagram. So see this diagram here. This point is when the atoms are far apart, and this point is when the atoms are coming to, if you see this diagram, the atoms are coming closer to each other, and this one represents energy. Yeah, this is the arrow here. It represents energy. So when you go up, the energy is what? Increasing. So when the atoms are coming to each other, the energy is seen to reducing, and at a minimum energy, they'll form what? A molecule. So most of the times, a molecule is formed at a minimum energy. That's when a molecule is formed. You know, if something is stable, the energy is at a minimum, and if something is unstable, meaning the electrons are always in an excited, they're always excited, and which means that they're always moving up and down, so they're unstable. So in a stable state, we know that the energy reduces. That's why you see minimum what? Energy. But when these and they calculated the distance which they must be far from each other for them to form this molecule. So if the distance is 0.7 Armstrong, they will form a molecule. But if they come really closer to each other in such a way that the nucleus here and the nucleus here is, the nucleus for this one and the nucleus for this one is very, very close, you see a repulsion, because this nucleus here is positive, this nucleus here is positive. So you see a repulsion, you see them breaking or going away, which is here the sudden shoot of what? The sudden shoot of energy in such a way that they are separated. So that's how a molecule is formed. So here I'm just trying to tell you guys that a molecule which is stable is formed when energy is reduced and the forces between what is increased. The forces between a nucleus and the electrons of another atom of other atom. For example, I can say the nucleus of this one and the electron of this of hydrogen 2 and the nuclear the electron of hydrogen 1 and the nucleus of hydrogen 1 come close to each other. That's when they form a molecule. So that's the first way of forming a molecule. That's a first way of how you can form a molecule in such a way that here they're dependent on electrons which are in between. So this one where the electrons are the ones which brings the nucleus together and are the ones which forms the molecule, we call it liaison liant. They call it liaison liant, meaning something which is similar is coming together and is forming what? Is forming a molecule. So here you see, here this is just I'm just representing a what? Two atoms. This is I can say the orbital S. This is just representing the orbital S. Two orbital S, which are moving in the same direction, like which are moving close to each other. Yeah, which are moving close to each other. Positive just meaning they are moving close to each other. They are moving close to each other. They are not moving in a different direction, but they are moving to each other. They are not repelling, but they are moving toward to each other. You see that they'll form one molecule. This is a molecule orbital. So they'll just add up and they form one molecule. They have formed a molecule. Yeah, it's just the same thing if I write it like this. Yeah, just the same thing. So there's nothing really different. So they form one molecule. So this is the first molecule which you can form. This is the first in the first case, and we call this one liant. The first case you can form a molecule like this. But there is a second case, because we know that what you should know that selon mécanique quantique, le nombre d'orbitales combinés doit être égal au nombre de molécules formées. So even though this one is not clear, so here is just saying that if I'm adding two number orbitals, this is S, since it's for hydrogen, I must form two orbital orbital molecules. Orbital molecules, when I say orbital molecules, just when they bonded together. So I must form two different orbital molecules. So I've only formed the one, meaning I have to find what the other one is, like the conversion of what? Conversion of matter. We can say conversion of matter in such a way that whatever you add, that's what you should form. That's the conversion of matter. So here they're just doing like conversion of matter. So here they have formed one, meaning I have to form another one, or there's other possibilities of forming the other way of forming a molecule in another way. If I can put it in a simple terms, there are other possibilities of forming a molecule in other ways, and this is the way which we're going to start here down. So you see here, this is don't get confused. This is the diagram for energy, and this diagram for energy said that if the electrons are in between, you form, like for this one, the electrons are in between. If there is positive, meaning they're moving towards to each other, the same direction, you form a molecule liant, which is stable. And this molecule, which is stable, it has less energy. That's why you have seen here the energy is less. The cut down bar here, it means the energy is less. Then there's another case where these you have two orbitals for hydrogen, but these orbitals they are arranged in such a way that the electrons are outside. Here they're just positive and negatives. They are not charges. They are just, I'm just trying to show you that they are moving the different way. They are moving in different ways, because they are, so it's possible to have two atoms which have electrons in the middle, and two atoms which have electrons outside, which are not in the middle, to bond to form molecules. So there are two possibilities here. There's a possibility of having electrons in the middle, or the possibility of having electrons outside. So when you have electrons outside, and it happens that these atoms, hydrogen 1 and hydrogen 2, they are close to each other. These atoms, when they're close to each other, they'll be close to each other, but since hydrogen, this one is positive, the nucleus for this nucleus is positive, and just this nucleus is positive, and imagine they're coming together, meaning they'll never add up, they'll never form one, they'll never form something like uniform. There'll be always a slight repulsion. They can form there'll be slight repulsion in such a way that the bond won't be like the bond will be in the form of broken. Yeah, it won't form a bond which is like together, but it will form a bond which is in the form of broken. That's why you see here, when I add positive plus negative, it will give me positive and negative, which is broken. So there are two ways. So this is liant. The first one is liant, where they add together to form a liant at lower energy. That's a liant. When I say liant, meaning of the same sign, they come together, they are moving, the electrons are in the middle. Then when I say antiliant meaning something which is not bonding, something which is repelling each other, that's antiliant. And if something is repelling each other, meaning it didn't even share the electrons. So meaning it's unstable and its energy is higher. That's why you see the bar is higher. So here, see, these are the hydrogen atoms which these are hydrogen atoms which I'm adding together. So there can be two ways of representing this hydrogen atom. Either the electron can be in between the electrons and they give me a uniform, or the electrons can be outside the nucleus and it give me something which is breakable like this one. So those are the two cases always when you go under molecule, under field orbital the molecule, you can find the two cases of how the molecule can be represented. So it can be represented in a breakable form or in a form which it has together. It depends how the electrons are arranged. That's what it depends. So yeah, so it depends on how the electrons are arranged. Yeah, I don't know if it's clear. Yeah, so someone asked me to repeat on the diagram. Yeah, someone told me to repeat on the diagram, and my network, my network is not the network is not that good. I don't know the width which I'm using today.
Yeah, it's glitchy.
So you can't even get me clear.
No, but now I can get you. Though a few minutes ago it was like skipping.
Yeah, so if it's skipping, you can tell me to where it's skipping. I repeat and all that. So that we go together. So under diagram, I'll start to repeat under the diagram. This is not the one. So what I was saying under the diagram, what I was saying under the diagram, I'll start from here. So when we talk about theories, the orbital molecule, we're talking about simply two atoms which are coming to, they are coming together, like two atoms, they are coming to form what? A molecule. So I said under theory, the orbital molecule, there are two possible ways of forming what? Molecules. So for example, you form hydrogen plus hydrogen, you know that it will give you a hydrogen gas. So what usually takes place when you're forming this hydrogen gas, when you're forming H2, your H2, what usually takes place? So there are two ways, I can say, there are two possibilities which you can have. So the first one is when you have electrons in there, when these are the two hydrogen atoms which are coming together have the electrons in the middle. They have their electron in the middle. Then these just represent the nucleus. This represent the nucleus. So what usually happens is, as I said, before bonding, you know that an atom, before bonding, you have an atom this side and an atom the other side. Imagine you have atoms which are far apart, hydrogen atoms which are far apart, and because of the electrons here, the nucleus of H2 will be attracted to the electron here, and the nucleus of H1 will be attracted to the electron here. So these, they will start what? Coming together. And you know that when they're still far apart, their energy is high in such a way that this one has one electron in the atom shell, this one has one electron in the atom shell, and it's not stable. And you know that an atom, if an atom is not stable, its energy is high in such a way that the electrons are always in the excited state. That's you know that one. So when they're coming together now, they're coming to form a what? A molecule. So imagine they're coming together to form a molecule, and each time they're coming together, you see that the attraction between the electron of hydrogen 1 and the nucleus of hydrogen 2, it increases, and the attraction between the hydrogen, the electron of hydrogen 2 and the nucleus of hydrogen 1 increases. And as it increases, as it reaches stability, you see that as it reaches stability, you see that the energy starts reducing also. So this is the diagram which I was representing to here. So here, the first part here, assume the atoms are very far from each other, and these atoms are coming closer to each other. So as they come closer to each other, you see that as they come closer to each other, you see that they have started, they'll start losing. This diagram represents, actually it represents energy. So this is the increase in energy. So as they come closer to each other, the energy is reducing because they are going to a state of stability. So the energy is reducing, Then at this point here, at the minimum energy, they form a molecule. And this molecule, you know, hydrogen, it means hydrogen will have 2 electrons, hydrogen 1 and hydrogen 2 have 2 electrons, meaning it has reached its what? Stability. And when it has reached its stability, its energy actually is what? Minimal. It's minimal, because when it's stable, the energy of the electrons, the different energy, the energy of electrons when they are just isolated is lesser than the energy when they bond together, because they form something which is stable. Then this is the minimal energy where they form a molecule. But it comes a point where these nucleus or the atoms, they will start, since there's attraction here, they'll start coming closer and closer and closer until if they just surpass this distance, 0.7 Armstrong, if they just surpass, even my writing is not clear. Yeah, if they just surpass this 0.7, it means the charge, the positive charge here and the positive charge here, when the nucleus, they come really close to each other, the positive charge of the nucleus hydrogen 1 and the positive charge of the nucleus hydrogen 2, they will repel each other, meaning there'll be a repulsion in such a way that there'll be a sudden increase in what? In energy. This is the sudden increase in energy. That's what I'm talking about. So here, basically, I'm just concentrated in the formation of the molecules here. So you can form the molecules first by, if the electrons are in the middle, you can form a molecule. Then if you form a molecule, if, for example, this one is orbital. This, I'm just representing an orbital, and we learned that orbital for hydrogen, it means it's room. So hydrogen, how many rooms does it have? It only have one S room, like it has one shell, so it only have one S room. So meaning this one S plus one S, which are similar, which are coming to each other, and the electrons that are in the middle, meaning they'll form a molecule, something which is uniform, something which is one if they add. And though you can also represent it in this form. You can also represent it in this form in such a way that this one just showing that they have come together, something like they have bonded. There's no space here. They have bonded. They have come together. So you can represent it also in this form. But since you have said that matter must always be what? be conserved. If I have 2 orbitals, I must also find 2 molecule orbitals. This is a molecule orbital which you find. So I must also find what? 2 molecule orbitals. So there must be another way of bonding the hydrogen atom, another way in where the electrons are not in the middle of these atoms which are coming together, but they're outside these electrons. So the first way, as I said, is when electrons is in the middle, which is liant. Liant when electrons are in the middle, and when electrons are in the middle, when they come together, they form what? They form a covalent bond, and this covalent bond is formed at energy minimal. Less energy, I can say so. Less energy. So this represents energy. So this one is formed at less energy. Then there's another way in such a way that this positive and negative, these are